Good morning, class. Hope you guys are doing good this Thursday morning. We are going to go ahead and get started with lesson 19 for today. There will be no problem set for you to turn in, but I do, however, want you to work out these examples and we will work over the problem set together. Okay? So, no homework, no assignment, but please go over this lesson with some notes and try to do the examples on your own. Okay? And we will move on. So, today's objective tells us I can solve problems by analyzing different unit rates given in tables, equations, and graphs. So, they're going to give us two different unit rates, and we're going to have to find them on either a table, in an equation, or on a graph. And we're going to have to compare two different unit rates and see which unit rate is either faster, better, more efficient, things like that. Okay, so let's go ahead and move on. We're going to start with exercise 1. Okay, this tells us Brian and Shanice are both training for a bike race and want to compare who rides his or her bike at a faster rate. Both bikers use apps on their phones to record the time and distance of their bike rides. Brian's app keeps track of his route on a table, and Shanice's app represents the information on a graph. The information is shown below. Okay, so we see Brian's table, and in 3 hours he rode 75 miles. Okay, and then we look at Shanice's graph, and we see that in 1 hour she rode about I would say 15 miles. Okay, so letter A says, at what rate does each biker travel? Well, we already know Shanice's, okay, because she hit 15 miles in 1 hour, okay, as we see here. So Shanice is going to be 15 miles per hour. Okay, and now we have to figure out how fast Brian is going. Okay, in 3 hours he traveled 75 miles, so we have to divide 75 by 3, and we would get 25. So Brian is going 25 miles per hour. Okay, let's move on. It says Shanice wants to win the bike race. Make a new graph to show the speed Shanice would have to ride her bike in order to beat Brian. Okay, so Brian's going 25 miles per hour. Shanice is only going 15 miles per hour. So I would say she would need to go, let's say, anything higher than 25. So let's just do 30. Okay, so Shanice needs to go 30 miles per hour. So I'm going to label my graph. This is my X is going to be my hours. My Y is going to be miles. Okay, I'm going to skip 1 and count by 1, 2s, 3s, 4s to 5. Okay, and on these I'm going to count up by 15. And I think that should be enough. Okay, so if we want Shanice to ride 30 miles per hour, that means in 1 hour we're going 30 miles per hour. Okay, so my X and Y, my first ordered pair is going to be 1, 30. So I'm going to go over to 1 up to 30, and I'm going to label my point there. Then 2 to 60. Okay. Then 3 to 90, 4 to 120. Okay. And we can finish our graph there. Okay, so if Shanice wants to win the bike race, she needs to go faster than 25 miles per hour. We showed an example of her going 30 miles per hour, okay, in order for her to beat Brian. Okay, so what we did, we compared a table with the graph, and we found the unit rates, and it showed us who was faster. We figured out Brian was faster because he was traveling 25 miles per hour, and Shanice was only traveling 15 miles per hour. Okay, let's move on. Braylon and Tice both work at a department store and are paid by the hour. The manager told the boys they both earned the same amount of money per hour, but Braylon and Tice did not agree. They kept track of how much money they earned in order to determine if the manager was correct. Their data is shown below. Okay, Braylon's money is represented in a equation. Okay, M equals $10.50 per hour, okay, times H, where H represents the number of hours worked and M represents the money Braylon was paid. So Braylon is getting paid $10.50 per hour. And I'm going to write this. Okay? Now we need to figure out how much money Tice makes per hour. Well, on his table, in 3 hours, he's making $34.50. So we have to divide $34.50 by 3. Okay, 3 goes into itself. Once we take away 3 from itself, and we bring down the 4. 3 goes into 4 once. Okay, we take 3 away from 4 and we get 1. Remember, we have to bring our decimal straight up and then drop the 5. 3 goes into 15 5 times. Okay, and all we have left is the 0. So Tice is making $11.50 per hour. Okay, so letter A tells us how much did each person earn in 1 hour. Okay, Braylon, $10.50 per hour. Tice, $11.50 per hour. Okay, was the manager correct? Why or why not? He was not correct, okay, because Tice earns $1 more than Braylon. So he was way off. $1 makes a huge difference. Okay? All right, guys. Let's keep on going. Keep up with the notes. Okay? Claire and Kate are entering a cup stacking contest. Both girls have the same strategy. Stack the cups at a constant rate so that they do not slow down at the end of the race. While practicing, they keep track of their progress, which is shown below. Okay? So Claire's is represented on a graph. Okay, we see here in 1 second she's stacking 5 cups. Okay, so Kate, hers is represented in an equation where T represents the amount of time, okay, in seconds. So T represents seconds, and C represents the number of stacked cups. So this is telling us that she is stacking 4 cups per second. Okay, on this graph, Claire's is 5 cups per second. All right. So at what rate does each girl stack her cups during the practice sessions? For letter A, Claire, 5 cups per second, and Kate, 4 cups per second. Okay. Kate notices that she is not stacking her cups fast enough. What would Kate's equation look like if she wanted to stack cups faster than Claire? Well, let's look at her current equation. C equals 4T. That means T represents seconds for time. Okay, that means for every second, she is stacking 4 cups. So if we were to change this equation, okay, to make it faster than 5 cups per second, all we would have to do is make it 6 cups per second. So an equation can be C equals 6T. Okay? And there she is faster than Claire. All right, guys, the lesson summary, and then we're going to do the problem set together. When comparing rates and ratios, it is best to find the unit rate. We need to find the unit rate when we're comparing two different diagrams, okay? Comparing unit rates can happen across tables, graphs, and equations. Everything we've worked on so far, okay, we've done tables, graphs, and equations. We need to find the unit rates from each of those, okay? So the problem set says, Victor was having a hard time deciding which new vehicle he should buy. He decided to make the final decision based on the gas efficiency of each car. A car that is more gas efficient gets more miles per gallon of gas. When he asked the manager at each car dealership for the gas mileage data, he received two different representations, which are shown below. So vehicle 1, the Legend, okay, that's the name of the car, gets 72 miles for 4 gallons, okay? And the Supreme gets 50 gallons for gets 50 miles for 3 gallons, okay? So letter A says, if Victor based his decision only on gas efficiency, which car should he buy? If Victor based his decision only on gas efficiency, which car should he buy? Well, we need to figure out how many miles each of those cars get per mile, okay? So let's look at the Legend. For 4 gallons, they get 72 miles, so we need to divide 72 by 4. 4 goes into 7 once. We take 4 away from 7 to get 3. Bring down the 2. 4 goes into 32 8 times. So there's our answer. The Legend gets 18 miles per gallon. I'm going to write MPG because that's how we represent miles per gallon, okay? Now, we need to look at the Supreme. With 3 gallons, it gets 50 miles. So we have to divide 50 divided by 3, okay? 3 goes into 5 once. We take 3 away from 5 and get 20, okay? 3 goes into 20 6 times. 6 times 3 is 18. We take that away from 20 and get 2. Now, we have a remainder of 2, so we have to add a decimal and a 0. Okay? 3 goes into 20 now after adding or bringing the decimal straight up. 3 goes into 20 6 times again, and we get 18. And we take 2 away. Now we have to add another 0. Okay? And 3 goes into 20 6 times. And we're going to keep on going like this forever and ever. So let's round to the nearest tenth. Okay? The nearest tenth is this first 6. We look at the second number. If it's bigger than 5, if it's greater than 5, then we round up. So, approximately, the Supreme gets 16.7 miles per gallon. Okay? So, if Victor based his decision only on gas efficiency, which car should he buy? Well, he should buy the Legend. Okay? Let's move on. After comparing the Legend and Supreme, Victor saw an advertisement for a third vehicle, the Lunar. Okay? That's the name of the car. The manager said the Lunar can travel about 289 miles on a tank of gas. If the gas can hold 17 gallons of gas, is the Lunar Victor's best option? Well, we have to do the math. We need to figure out how much it makes per gallon. So we need to divide 289 by 17. Okay, 17 goes into 28 once. We take 17 away from 28 and we get 11. Okay, now we have to bring down the 9. Okay, 17 goes into 119. Let's see. Let's try 17 times 7. Okay, this is 49. 7, 11. Okay, so there's our answer. Okay, 17 goes into 119 7 times. So the lunar gets 17 miles per gallon. Okay, is lunar the best option out of the three? No, the legend is. Okay, and that's our answer, guys. All we did was compare two different diagrams to find unit rates. We figured out that the Legend got 18 miles per gallon, while the Supreme approximately makes 16.7 miles per gallon. And then when we added a new car, the Lunar, we figured out that it only gets 17 miles per gallon, so the Legend still ends up on top as more efficient in gas mileage. Alright guys, I hope you worked these out while we were going over this. You need to know this information. Okay, there's no problem set, no assignment. Thank you for your hard work, and have a great day.